Hello and welcome to my presentation of our paper application of energy informatics in Danish research projects. I am happy to present this paper at the EnergyInformatics.Academy conference 2022. This paper was written by me, Danish together with Maersk and Nørregaard. So, writing this paper today, approximately 50% of electricity in Denmark is supplied through wind and solar. And as we know, renewables, they can challenge the security of supply. And in order to balance out, information systems have been identified as a core component for balancing this. And combining information systems and energy research in this way is often referred to as energy informatics. However, currently there is not a lot of information on the current trends and challenges of energy informatics research outlined, and due to the radical information expanse and challenges, which challenges the possibility of exhaustive state-of-the-art review, investigating nationally funded projects in a pioneer country can help. And in this case, we are looking at Denmark, and in this way, looking at the nationally funded projects can then be reflected in a global setting. And due to the lack of previous literature, there's also a current lack of research direction and how the future of the research direction should be determined. So in order to collect Danish publicly funded energy research, the website for the Danish Energy Agency was used in Giforskning.co. The website is annually updated, and there's a collaboration between Danish energy funding programs. The primary funding programs that were considered here is the Energy Technology Development and Demonstration Program, also known as EUDP. It's the ELFORS program, the Innovation from Denmark program, and then the Green Labs DK. Green Labs DK is a part of the EUDP. And the available information that could be extracted from this website was things like project title, the main responsible party of the project, what the project aimed to do, and a description, the project period and the year the project was funded, what the overall budget of the project was, how many partners and which partners were involved, what kind of funding program gave the funding, the project type, what the project focused on, any important contact information, and then if the project had finished, possibly a final report outlining the primary findings. So in essence, what we wanted to do was collect previously funded Danish energy research projects with then selected categories, then use keywords for finding energy informatics projects, and then through quantitative and qualitative review, look at how the current energy informatics research projects is being conducted. So here we looked at an initial 1,756 projects divided on 3 categories: energy efficiency, others, and smart grids and systems. We then introduced the keywords digital, IoT, cloud, intelligent, and data, and filtered and ended up with 207 projects total. The collection of results responded differently to the keywords. We can see primarily data and intelligent were frequently emphasized in the projects, whereas IoT and cloud were not as frequently used in the projects. And here, as I noted, projects in this figure may respond to more than one keyword, entailing that the sum of the keyword responses may exceed the number of returned projects. Examining the development of energy informatics projects over the years, we can see that there has generally been an upgoing trend of both the number of projects per year and also the public funding amount given per year. Furthermore, if we look at the number of projects funded for each program, we can see that the UDP funds the most projects. However, if we compare this to the supplied funding amount, we can see that the Innovation Fund actually provides a higher overall funding per project compared to UDP, whereas GreenLabs.DK, which is also a part of UDP, actually also gives a very high funding amount per project. However, this is probably due to GreenLabs.DK being primarily focused on large-scale test facilities. Examining the project duration figure over here, we can see that the average funding given, depending on the amount of years the project is running over, that up until 3 years, there is an increase in the average funding, and then there is actually not any thing to win having a longer project than 3 years. However, at 5 years, there is a high average funding. This might be low due to a low number of overall observations. But examining the numbers here, it seems like at 3 years, the curve kind of tips down again. And at 5 years, there's a high amount of funding to get. If we then look at the number of projects that were of a given duration, we can also see that actually 3-year projects is also the most commonly used, whereas anything more than 4 years is not very common, with the longest projects being 8 years. If we then look at the partners of projects, this is interesting because EnergyInformatics is an inherently interdisciplinary research field, and therefore the collaboration between partners is an essential part of it. And if we look at the number of projects that have a number of partners, we can actually see that most of the projects only have one partner, with a decrease in amount up to 39 in this case. And also looking at the number of universities participating in projects, we can see that most of the projects have either 0 or 1 university partner, and anything more than 2 is very unlikely. Of course, the knowledge sharing from universities into companies and projects is very important. So therefore, not having any university partners in a project can be problematic in terms of using the expertise from these knowledge institutions. We then continue to do word cloud associations, where we use the frequency of title words of the projects and saw how frequently these were there. And the bigger the word is, the more frequent it was. And here we can see that energy optimization and energy efficiency are quite high, intelligent, of course, also. But also we see specific use cases, such as buildings. In this case, we even have a small district heating here. So it seems like energy optimization and energy efficiency very important. Also heat pumps out here on the right side, and lights in terms of LED and lights here have also been discussed with the ventilation here on the left side. And actually, we can look at this development of word clouds over the years, and we can see that in 2011, there was one emphasis on buildings and even geothermal and intelligent control of this, whereas in 2021, there's a higher spread with energy optimization and intelligent control, more related to maybe ventilation, heat pumps, buildings in this case. We could then place each project in two of the primary value chains using EnergyInformatics, which is the energy value chain, data value chain. So every project's primary emphasis was placed accordingly. And we could then compare this in the pivot table. And here we can see, if we examine the energy value chain at first, that the predominant amount of projects are focused on the end user, with only a few on the generation and distribution side, some on the fuel. These were older projects because Denmark used to have a lot of oil production, so this was in relation primarily to that. And then specifically on the transmission, there is not a lot of projects happening there. And in terms of the data value chain, it was emphasized primarily in terms of data usage, whereas the other parts of data acquisition, analysis, and curation were not very frequent, and data storage also not that frequent. However, in some of the recent projects, we have seen more emphasis on this in terms of data lakes and data warehouses and so on. So giving an overview based on what we have been through here, we can see that the predominant amount of research focuses on concrete case studies with energy informatics tailored to the specific application. And it's generally seen from an energy system and grid perspective. The energy informatics have been generally seen used in terms of energy-aware control, and it's been primarily for buildings, lights, ventilation, heat pumps, transportation, and cooling. And then the review projects emphasize the use and application of data in specific cases. And this was, for example, for control. So as an outlook, this based on what we have been through, there should be an increased emphasis on sector coupling. Sector coupling has been discussed as a good way of allowing energy system flexibility, and using energy informatics to examine interactions and limitations between different technologies. And for example, Power to X could be an interesting opportunity. Then there should be more attention to the entire data value stream in projects, maybe outlining data strategies in projects before, during, and after the project is a good idea, so that the data can be used afterwards as well, promoting fair principles, so that the future research projects can actually build on some of this data if possible. It was seen that multiple of the projects actually collect the same data multiple times, so there could be reasons here to actually help in the future, where you can do some preliminary investigation on previous data. And also here, for example, in industries, there's a lot of data that is available but not currently being extracted because it is through third-party softwares. So there should be some emphasis on data collection, curation in this part. And then there is also a lot of emphasis on buildings and domestic consumers, where emphasis on industrial loads might be recommended, as the flexibility here is often higher, and then there should be a grid perspective or more a consumer perspective, so it is not only seen from a grid side. And then sector coupling can also be used here to include industrial loads and see if there are any synergies that can be developed. And then including multiple research institutions should be emphasized, as energy informatics is inherently interdisciplinary, and in this way we can learn from each other and help build better solutions through, and also disseminate the knowledge into companies, enterprises throughout society. So limitations in future work, these were high-level projects, and sometimes it's difficult to assess the contribution of the projects. And the public, we only collected from a single research database, and of course this could be extended into both national and cross-national projects to see tendencies and requirements there. Lastly, if you have any questions, feel free to contact me at the email here, and you can also see information about me here. I'm very happy I could present here at the Energy Informatics Academy Conference 2022. Thank you so much for your attention.